I don't know if it's worth going through the business part first or just going through the TNT and waiting until about 7:30 and assuming normal business procedures. So that being the case, maybe we just go right into TNT and let Mike do his thing. I think you've got an interesting presentation about antennas. So why don't we turn it over to you, Mike, there, KA4CDN. Go ahead.
Yeah, if I could just interrupt quickly, Mike's slides are on the website under meetings presentations. So anybody who'd like to download them now and view them could do that.
Unmute. Everybody hear me?
Yes, we can hear you now.
Yeah, you're good.
Okay. What about my slide or my screen?
Perfect.
Yeah, it's showing up for me.
Okay. All right. Well, this is interesting. See how this goes. Do I look professional and intelligent and professory?
Absolutely.
Okay. Well, I guess what I was asked to present what I've been using for a 160 meter antenna after a couple of the QSO parties and talking about my winter contacts. Several people had asked me about it, so Leon put me up to doing this presentation. So the antenna I'm going to present is one that I've been using for the last several years pretty effectively. I've had it up in several different configurations. I guess I'll preface all this with saying I'm just an experimenter. Like I said, I've gone through several iterations in preparing this presentation and writing this up. I had notes from when I had been working on these antennas and building them. As I went through analyzing them and such, I think I raised more questions and scratched my head on a lot of things. Probably did more research getting ready to do this presentation I did putting the antenna up. So with that caveat, just be advised that, don't take this as gospel, a textbook, proven science or anything like that. So buyer or listener beware. But anyway, the antenna that I've been messing with here and having success with is called an inverted L. And it's called that because of what it looks like. Doug, do you see my mouse when I'm wiggling it around on the screen? Little hand?
Yeah, it's showing up.
Okay, cool.
Yeah, it works fine.
But Mike's muted.
Muted by hello? Hear me now?
You're good.
Yeah,
Okay. The host muted me. So I don't know where I got cut off. It's an inverted L is what I'm going to be doing here. Electrically, it's a quarter wave ground mounted vertical, and it doesn't reach a full vertical height. It's just keeled over at the top, ideally at somewhere near 90 degrees, and fed against some sort of ground system. So here are a couple of examples I just copied off the internet, just to demonstrate sort of what it looks like. The second image here is very close to what I had here at my house for the longest time. I had it coming out my shack window until just a ground rod for the ground system. Rather than the window here, I had it way up in a tree and then kicked over. So for the longest time, I had it like that right next to the house. It was less than ideal. Here's another picture of somebody else's installation in trees. So again, it's inverted L because it just runs up vertically and then kicked over to the side, and the whole length is approximately a quarter wave. Let's see, can I go down? How does it work? Page down, no. Okay, so some of the characteristics of this inverted L, again, it's similar to a vertical antenna in that the current is highest at the feed point, which is close to the ground. It's fed at the ground. So it's mostly giving you a vertically polarized radiation pattern. Again, similar to a vertical. The horizontal part where it kicks over to top adds a little bit of horizontal polarization. My modeling, looking at it, doesn't seem like it affects it a whole lot though. It's very curious as you model it. as far as where the radiation goes. It doesn't become omnidirectional, so it definitely has an effect, but it's not as much as you might think. It is kind of curious in that regard. You'll read, if you research these on the internet, a lot of people claim that that horizontal section gives it some top-loaded capacitance, like a cap hat. I'm not sure I buy that. It's just a single wire, maybe at different angles and different lengths. Maybe it does add a little bit of capacitance, but I didn't see that in my modeling, so I question whether that's true or not. Next point is that horizontal section, oh, I already said that, makes it so it's not completely omnidirectional like a true vertical might be. It does have a nice low takeoff angle, which makes it good for DX versus like a dipole or something like that, which has at a reasonable height, the takeoff angle is much, much higher on a dipole or a off-center fed. And like any type of vertical antenna, it definitely needs a good ground system, whether it be a good earth, like over the ocean, or radial system, or a resonant radial, which you might call it a tuned counterpoise. And just out of an interesting fact here, I just noted that this the expedition down the Ivory Coast, they had one of these set up down there. And I don't know whether they had it over the marsh or what. I actually wrote them and asked them to give me some details on their antenna that they were using for 160 meters. And apparently I didn't understand my request. I did respond with a link saying I was in the log and here was how to request a card. So I didn't get a good answer, but I'd be curious to know how they had it set up, because, you know, looking at their website, there wasn't a lot of trees or tall, you know, trying to get a pole up very high would be difficult. So I would have liked to have heard back from them, but so be it. So here's I got a couple examples of some theoretical radiation patterns for this inverted L. I modeled it in a couple different, I modeled it in easy neck, I modeled it in 2-neck 4, or 4-neck 2, I should say, to get different variations on different configurations of the antenna. So this configuration here, wire 1 is a tuned counterpoise. And then here I have wire 2 is the vertical section and 3 is the keeled over part. This, I think, was like 55 feet, 50 feet. And the whole thing being a quarter wave, that makes like 120 something feet long. So 2 plus 3 is roughly 120 feet. And you can see here roughly the pattern is not truly omnidirectional. It's not a real good picture. I've got some other slides later. But mainly what I wanted to show here was the far field radiation pattern and the main lobe here being at a nice 26 degrees. So, you know, it's kind of verticalish. So it makes for a pretty good DX antenna, I do believe. And you will see a lot of people on the 160 meter, you know, boards and stuff will talk about, yeah, the inverted L is a nice 160 meter antenna. And you compare that to, you know, something like a dipole or off-center fed at a reasonable height. You know, if you got trees or around here, you know, 50 feet, I guess some people are luckier, got some bigger trees, you get up a little higher, but still, I mean, your radiation pattern off of something like a dipole is going to be pretty much straight up. You know, it doesn't have any of that nice vertical component. So my reason for looking at the inverted L was space limited. You know, there's no way I'm going to get a dipole up, much less a dipole at a reasonable height. So some of the downsides are with the vertical lightness, you can have a higher noise level, static level. Like I hear thunderstorms and stuff when they're coming on, they're really, really bad. So, you know, why is that? You read, some people say that this is a true fact. Other people say it's not, that there are more QRN susceptible. Some of the reasons being on that is a lot of the natural noises, QRN travels via ground wave. And since they're on the ground, the horizontal component gets attenuated by traveling along the ground. So you get more of the vertical component of the noise hitting your antenna. Switching between, you know, the vertical and some of my other horizontal dipoles and stuff, it's kind of hard to compare because my horizontals aren't resonant at 160. So I can't really judge, but that's what you'll read. And they aren't great reception antennas. If you're going to do a lot of 160 meter, you really need some sort of beverage, some sort of loops, directional loops or something to knock out the noise in certain directions. You know, again, this being omnidirectional, it's going to hear in all directions more or less simultaneously. So my goal for my antenna here was I wanted it for 160 and 80 meters. So I needed some sort of trap. I had to fit in a reasonable lot. So my lot is about 1/3 of an acre. So not a very big lot. I've got tall trees on the edge of my property, so incorporate those. Can't put it in the middle of the property because my house is in the middle of the property. Target frequencies were the CW portions for specifically the SKCC, the Straight Key Country Club, Straight Key Century Club, which I enjoy playing on that. And cheap. I don't want to spend any wire if I'm just experimenting. So first, starting with the trap design, again, not spending any money, I just went with a Coax trap. And here's a link, which will be on the documents that Doug posted for me. It's a Coax trap design. So basically, you put in there the resonant frequency you want. And the way this thing works, it's a coax wrapped around a insulating form, a cylindrical form, and you take the braid of the coax and attach it to the center of the coax. And what happens is the coax has a capacitance value that you can look up that's formed between the center and the shield and the dielectric, which is the insulation between them. So that becomes your capacitance, and then the coils become the inductor. And so between them, you basically end up with a tuned circuit. And again, there's a program there on the internet that you can download. You don't need to install it, it's just an executable you can run. And you put in there your form size, the diameter of it, your coax choice, and your target frequency, and it will tell you the number of turns. So that's the program I ran to come up with my trap. And again, I wanted it to be 80 meters. So what you want to do is target your trap frequency not at where you're going to be operating, because you don't want this thing with high currents and high voltages while you're operating. They get hot, and you have high losses. So you want to go below or above your target frequency. Here's the program itself, as I was saying. Coaxial traps is the name of the program. So yeah, you enter in your frequency. Here I entered in my target frequency. I didn't know where I was going to come out. If I tried to go low or go high, you know, it's never going to be exact. So I figure if I go exact, it will end up being high or low. And that's ended up what the case was. And the things to take away from here after you do that is the number of turns. It gives you the length it'll be. It gives you your capacitance and your inductance that you're going to end up with, which is nice when you're modeling it. You can plug those numbers into your model. Let's see what else. There was a coax length. So that's how long you cut your coax that you're going to wind on the form. So it's a really nice program. There's a number in here. I'm trying to think if it's end sensitivity. Oh no, this here, length diameter. You want to read up on this program when you use it, but you want your length diameter ratio here to come around a 0.5. Depending on what coax you pick and your form factor, your coax, let's see, what your form diameter here, this number will change quite a bit. And you want to keep this ratio about 0.5. Otherwise, you have high losses and some other side effects that you don't want, which I can't remember off the hand what they are, but you want to shoot for 0.5. In my notes here, yeah, you don't want it to beat your resonant frequency. And then the effect that it has on your 160 meter, then for me, was it acts like an inductor. So it's like a loading coil. So the overall length of the antenna will be slightly shorter. So here's my design for my lot was I had 17 gauge stranded from when my dad worked at the Electrolux vacuum cleaner. I've got a company, I've got huge rolls of this stuff. So 17 gauge insulated is what I use for the radiator. I had some 14 gauge non-insulated stranded copper, which I used for the counterpoises. And then for the lengths, I used the standard 233 over the frequency to get a quarter wave length as a starting. So here's the model. I think this is in 4-neck 2. But I've got an 80 meter counterpoise one direction, the 160, because my lot's not big enough. It runs to the side and then runs to the front. So it kind of runs all over the place. The vertical here is, I think I ended up with 51 feet, and then it kicks over and it slopes down at an angle. I got some photos later. And here is the predicted SWR sweep. So it's low at here, done not good resolution, but trust me, that's 1.85. And then here was 3.55 in the model, 3.53. Here was the predicted radiation patterns. And this is where things get interesting. So you can see, maybe you can see, it's the major lobe here is up. This is, let's see, what do I got here? This is in the counterpoise here. So the major lobe on 160 meters is following that counterpoise. And on 80 meters, you can see it goes the other way because the 80 meter counterpoise sort of run in the other direction. So I thought that was interesting. I think that's what I'm seeing when I'm talking. Here's the pattern, a little bigger. So my installation here, this minus 180 degrees down is pretty much due north. 90 degrees is due west. So the major lobe in my installation is to the northwest, which is exactly where I wanted it, just by chance. I mean, I had no choice. That's where the trees are, my property runs. So it worked out quite well. 80 meters, on the other hand, points the other direction. So that's not quite so good for me, but I was more interested in 160. Here's some of the current distributions. The top one is for 160 meters in the model, and the bottom is the 80 meter current distribution. And you can see it is really interesting. So the 80 meter counterpoise is this wire here. You can see no current on it when operating on 160 meters. And then when operating on 80 meters, you can see the current distribution on that counterpoise is quite high. Hardly anything on the 160 meter counterpoise, and you can see the trap here taking effect. So thought that was pretty cool. For building, so this is my trap that I built out of the Coax. So you can see my form here. I think I used a 4-inch form, if I remember. And then the turns, again out of the cat. And so to tune this thing, there's a bunch of different ways. If you had a 2-port analyzer, which I didn't have it at the time, I just made a loop of wire, and one side grounded on the MFJ. I'm pointing, you can't see me. One side grounded on the MFJ, the other side just sticks into the center of the SO259 on the analyzer. And then you just take the trap and you dip it through the wire. And when you have it at the frequency you want it, you'll get a 0 SWR because that's where it's resonant. And then to tune it, you just spread the coils in and out a little bit, and you can pretty much put it right where you want it. I was pretty shocked. I've made several of these. I made some for 30 meters. I've made a couple of them now for 80 meters. And it's amazing how accurate you can get them. So I'm pretty pleased with how well these things work. So here's a picture of my backyard and the antenna, and hopefully you can't see it. That's one of the benefits. The neighbors don't see it. And here's so here I highlighted the wire. So there's a tree here, and I've got a pulley up on top. The wire just runs, I've got it wrapped around a nail to secure it at the bottom. It's insulated, nailed to the tree. Goes up to the pulley, it kicks over. I've got the trap up there, and then it's sloping down at a fairly decent angle. And I've got some shorter trees in the front where I've got them tied off. So there's a little insulator there, and then the string goes to my front yard, keeping that inverted section hung out there, or the horizontal section, I should say, hung out there. The counterpoise, this is my side yard over here where you can see the pine bushes down here. It's a big dip down in there. I took this picture today. So the counterpoise runs about 8 feet over to the side yard and then just runs down that dip following the grade, runs back up to a cherry tree here in the front and is just tied off there. It's an uninsulated wire. It's bare copper. And along the way, it drapes on a couple of little bushes and trees. And I've got some strings hung in other trees holding it up to keep it high enough to where the deer aren't going to take it out. So it's probably on average 6 or 7 feet off the ground. The 80-meter counterpoise runs from this tree where it's nailed, pretty much straight to where I'm standing, and then tied off in a bush. And again, it's about 7 or 8 feet off the ground. And that's it. So, and then at the feed point, the coax just drops down and just runs along the ground. It's pretty much buried at this point, and then into my basement where my shack is. The feed point, I've just got a 259 soldered. You know, the ground section, just one counterpoise goes 80 meter, the other's the 160 meter, just soldered on. The wire here, you can see the insulated wire nailed to the tree and into the center of the conductor. And then I made a choke by winding the coax, thinking to keep the common mode off, but I don't think it does any good at all. I'm looking at some charts and such like that. At 160 meters, those 7 or 8 turns I've got, that diameter, it's not doing anything. I'm sure it's totally ineffective. On the other hand, the coax, and this is something I've talked to people about, I don't know if it's true or not, but I think that coax running in the dirt to my shack probably attenuates shield current. Maybe somebody has some comments on that, but I definitely don't have any current. I've measured the current on the coax in the shack, and there's nothing on it. So something's working to keep it down. So to tune this thing, what I did was first started with the 80 meters. I had this wire cut, and I just kept taking in wire until I got 80 meters where I wanted it. And then did the 160 meters secondarily, just dropped the end and just shortened it up until I got the 160 meters tuned in. And also, just as an interesting side note, I tried disconnecting the counterpoises, and the SWR just goes nuts. As soon as you connect, so I connect the 160 meter counterpoise, 160 meters comes in SWR just perfect, 80 meters is still whack. I connect on the 80 meter counterpoise, and it comes right on the money too. So just as a sanity check, I checked that to see if the counterpoises were in fact working or doing anything, and they most definitely are. As I mentioned earlier, the very first one of these I just had these set of counterpoises. I just had it staked to my house ground, and I don't think that was working very well. And so I did lay out probably 6 or 7 radials, and that brought the ground resistance down some. But I still don't think the antenna was that effective, just because it was close to the house, maybe, or maybe I didn't have enough radials. But in my mind, if you can put counterpoises up. I'm kind of preferring those, at least for this antenna, over a radial system, unless you've got a lot of room and you can put out a full radial field, which I did not have. So here is my. So I measured this just a couple of days ago at the antenna feed point. So I took my my rig expert out there and took this data at the feed point. So as you can see here at 1855, which is where I was shooting, the SWR is extremely nice. This was the 80 meter SWR, a little off where I wanted it to be, but still, very acceptable. This is the reactance plot. You can see here at 1855, is about where it's X is, well, let's see here. X is 0, a little higher than that. But wait a minute. Resistance here, 50 ohms is where I wanted it, but I guess what am I looking at here? RX. So my X is a little higher than where I want. So it's a resonant a little higher. So maybe I trimmed a little too much off. I don't know. Same here on 80 meters. Looks like it's resonant a little higher, but 50 ohms down where I want it to be. This is just another full sweep. And you can see, you know, so it's just not a dummy load. I mean, at frequencies outside of where I wanted it to, you know, the SWR goes very high. And then, you know, the final proof of the pudding here, this is, my results have been, this is over a course of probably, I think 4 years, maybe a couple of years on the I call it my failed installation, and then a couple of years with what I just showed you. For DXCC on 160, I've got 54 countries worked with 42 of them confirmed, so I'm pretty pleased. Most of that work CW on 160 meter anyway. And then here's a list of the countries I've worked with, the ones that are over 4,000 miles in yellow. So I'm pretty happy so far. You know, and it seems like, again, my issue is I can't hear very well. It's just a lot of noise. I think if I can hear better, I could probably work more. It seems like if I can hear them, I can pretty much work them. I do have an amplifier, so this isn't 100 watts. You know, I definitely, if I hear something I want and they're not hearing me, I turn on the amp and up the power a little bit. So I am cheating in that sense, I guess, a little bit. My big goal here is worked all states. So I'm up to 49 states. I've got Kansas not confirmed, and I haven't worked Alaska yet. So that's what I've got there. So I don't know if anybody has any questions. You probably didn't know you could have so much fun with just a piece of wire, but I certainly had fun building it, playing with it, and writing this up. Had myself scratching my head quite a bit on questions I was raising as I was trying to figure out exactly what I had to present it. But it sure was a lot of fun. So that's all I've got.
Mike,
it's Harry. I've got a quick question. You had a slide a couple back where you tuned it. You said you tuned it on 80 and you tuned it on 160. And that was tuning those counterpoises to get your SWR down?
No, the counterpoises, I didn't have to mess with those at all. I think they're somewhat detuned because, you know, they're laying in tree branches and all the rest of it. So the tuning was just on the radiator wire itself, the main wire.
I see. Okay.
That, lengthening that one. And the counterpoises I didn't touch. They're cut. Well, they were cut for exactly a quarter wave. When I first put it up, since I first used them and put them up, tree branches have dropped. They've broken several times. So I've, you know, twisted them together and soldered them. So they're probably a little shorter now, but I haven't seen them make a big difference, at least where the frequencies are resonant. So I think it's more critical to get the resonator right.
Okay.
Mike, I have a question. You said you use the amplifier with this antenna. How much power can you put into it before you do damage to the antenna? Do you know?
Well, that's an interesting question. I put 1K into it, and I haven't noticed any arcing or fireworks or sparks or anything. But having said that, this is the second coax trap I've had up there. The first one in a windstorm busted up and came down out of the tree, and it broke and came down. And looking at it, I'd used a really light plastic form, and it had grooves in it where the coax was wrapped. So I don't know whether that thing was getting hot and had actually melted in there, or if it was due to UV degradation or what. I kind of think that the coax was getting warm and had melted in. But I don't know. I mean, it's so high up there. I definitely didn't see any arcing or sparking or anything. So I don't think that was an issue. But it might have gotten a little warm. I don't know. Hey, we got toilet paper. Score. I was getting desperate.
Hey, Mike.
Yeah.
Yeah, one comment and one question. This is Mike, VKN. I've watched a couple of YouTube videos on guys that have built antennas with counterpoises, and they said, both of them said that the antenna will be highly directive in the direction of the counterpoise. And I think that's what you said you saw, right?
Yeah, but here's what where'd it go? Yeah, there's the current in there. So the counterpoise here is running at a minus 180 degrees, but then I've got the 80 meter counterpoise is over here at 60. So I think that skews it a little bit. And I think that's why mine is not following the counterpoise.
Okay, that makes sense.
Yeah, but I also modeled it. I modeled this as a ground mounted with no counterpoises on it, just into the ground. And
right.
What I didn't understand there was, that's why I didn't put the slide in, because I couldn't explain it. The main lobe goes the opposite direction of the horizontal section's kicked over. So in my instance here, on this particular model, it's more or less following the horizontal section of the upper part of the antenna, which happens to be in the same direction as the counterpoise, more or less.
Oh, okay. And that might
the radiation prediction when I modeled it went in the other direction. So I'm scratching my head. That's one of the things I can't quite explain. So
that's why we love to experiment. Yeah, you get good experiment. Hey, I the question I had was, is there any sensitivity between the length of the horizontal and the vertical section that you know of?
Say that again.
Well, is there any sensitivity, or is there any anything that sensitivity to the ratio between the horizontal and vertical section, their lengths?
I'm sure there's got to be. I mean, as I mentioned earlier, I think kicking it over, people will say that adds capacitance to it. So, if it was straight up, if the ratio was straight up and less kicked over, I would think to be less capacitive, but I'm dubious of how much capacitance is added by that single wire. So I think it more affects probably the radiation angle, the patterns you get. It turns more into a true vertical, your takeoff angle is going to get lower and lower.
Okay, that makes sense. Yeah,
really better. My mind would be better. It also seems like, let's see now, I'm going to say something and then I'm probably going to question it. But when I also modeled this earlier today, just as a pure straight vertical, and into the ground, and the ground resistance, I think is something like 20 ohms. But when you kick it over, that goes up a little bit. So somehow the kicking it over seemed to change the impedance that the antenna sees with Earth. And I'm not sure if that's due to some anticapacitive or not. So as I said, there's tons of questions I've got, and I would love to sit down with people and put our heads together and see if we can figure out some of this.
Yeah, I may build one to get some more data. So anyway, thanks. This is great.
Yep. Okay. Thank you.
All right. So anybody else have any other questions for Mike? Sounds quiet. So Mike, thank you for very good presentations. Trying to get me inspired to think of putting an antenna up as well like this. Try one out.
Okay, cool. Thanks.
See if I can maybe hide one somehow in my condo here. So, well, good stuff.